Hello dear students, Assalamu alaikum. I hope you will be fine. My name is Engineer Mir Masocha. I am lecturer Department of Technology, Sarhad University of Science and Information Technology, Peshawar. As I am teaching you the subject design of hydraulic structures, it is for BTech Civil and the credit hour for this course is 3. And today is your lecture number 3. In lecture number 3, we have the first topic, layout of diversion headworks and its components. A typical layout of a canal headworks is shown in figure below. Here you see the figure of typical layout of a diversion headworks and its components. Such a headwork consists of different components. These components are pier, under sluices, divide wall, river training works, fish ladder, canal head regulator, river training works. In river training works we have guide banks, marginal bunds, spurs and grouties, etc. Also we have shutters and gates, and also we have silt regulation works. So these are the different components which are included in a diversion headwork. Also you can see the figure. In the figure these are shown. The diversion headwork is constructed across the river. River is flowing in this direction and a diversion headwork is constructed across it. These are the marginal bunds, and here is the guide bank. These are the under sluices. Under sluices are used for silt regulation works. This is the canal head regulator with gated opening called head sluices, through which the clear water is regulated into the off-taking canal. This is the divide wall. This is the normal weir portion, that is weir proper or main weir. These are the weir divided into bays with piers. This is fish ladder. Lengths divided into bays by piers. Each bay is provided with gates so as to act as an opening of controlled height, and these portions are known as under sluices portion. So this is the typical layout of a diversion headwork. First of all, we have weir. As we already studied in the previous lecture, weir is a barrier constructed across the river. It aims to raise the water level in order to feed the canal. Clear? So weir is a barrier which is constructed across the river for the purpose of raising the water level to feed the off-taking canal. The next component we have under sluices. The under sluices are the openings provided at the base of the weir or barrage. These are small openings which are provided at the base of the weir or barrage, whichever structure you have. These openings are provided with adjustable gates. Adjustable gates are installed in these openings. Normally the gates are kept closed. The crest of the under sluices portion of the weir is kept at a lower level 1 to 1.5 meter than the crest of the normal portion of the weir. Means that the height of under sluices portion is about 1 to 1.5 meter above from the normal portion of the weir or crest portion of the weir. The suspended silt goes on depositing in front of the canal head regulator. As we all know, when water flows in river, it has some silt or other materials. These silt keep depositing in front of the canal head regulator. When the silt deposition becomes appreciable, the gates are opened and the deposited silt is loosened with an agitator mounting on a board. When the silt deposits enough in front of the canal head regulator, then these under-sluices gates are opened and this deposited silt is loosed with the help of an agitator which is mounted on a boat. The muddy water flows towards the downstream through the scouring sluices. The under sluices are also known as scouring sluices. When we agitate the loosened silt and loosen the silt, the water becomes muddy, and when we open the scouring sluices or under sluices gates, the muddy water flows towards the downstream side, and as a result the silt removes from the headworks. The gates are then closed after when the muddy water flows down the downstream and the silt removes from the headwork. At the end, the gates are closed. The main function of under sluices are: number 1, to maintain a well-defined deep channel approaching the canal head regulator. That is, to maintain a well-defined means clear channel, clearly deep channel towards the canal head regulator. Number 2, to control the entry of silt into the canal. These under sluices are constructed in a diversion headwork for the purpose of silt controlling, or to control the entry of silt into the off-taking canal so that clear water enters the off-taking canal. Number 3, to help scouring and of the silt deposited over the under sluices floor and removing towards the downstream side. Means that to remove the deposited silt which is deposited at the diversion headwork, and through these under sluices or scouring sluices, this deposited silt is removed and move it towards downward side. Number 4th one is to help passing the low floods without dropping the shutters of the weir. Also, when low floods came in the river, these under sluices gates are opened without removing or dropping the shutter of the weir, and the low floods pass over these gates of the under sluices. Next one is the divide wall. What is the divide wall? Divide wall is a long wall constructed at right angles in the weir or barrage. It may be constructed with stone masonry or cement concrete. As you see in the figure, this is the diversion headwork. It is constructed perpendicularly to the weir, and it is constructed of concrete or stone masonry, or it is constructed parallel to the river water flow. On the upstream side, the wall is extended just to cover the canal head regulator. On the downstream side, it is extended up to the launching apron. As you see, on the upstream side, it is extended up to this point, up to which it can cover the canal head regulator, and on the downstream side it is extended up to the launching apron. The main functions of a divide wall are: number 1, it separates the under sluices with lower crust level from the weir proper with higher crust level. Means that it separates the under sluices portion from the normal weir portion. This is the function number 1 of a divide wall. Number 2, It resists the overturning effect of weir or barrage caused by the pressure of the impounding water. When we construct a diversion headwork by constructing a weir, the water comes and deposited here, impounding here or stored here. As a result, they apply pressure on the structure. So this divide wall helps in the stability of the structure, as the impounding water tends to overturn the structure, and this divide wall helps the structure against the overturning effect of the storage water. Number third, it helps to keep cross current, if any, away from the weir. So the divide wall also protects our structure against the cross current, which is also known as eddies current, in which the water starts revolving. The next component we have fish ladder. The fish ladder is provided just by the side of the divide wall for the free movement of fishes, as rivers are important source of fishes. As we all know, the important source for fish as we all know, a river is the important source of fishes. So for this purpose, a fish ladder is provided just by the side of the divide wall for the purpose of free movement of fishes from upstream side to downstream side. There are various types of fishes in the river. The nature of the fish varies from type to type, but in general the tendency of fish is to move from upstream to downstream in winters and from downstream to upstream in monsoon. This movement is essential for their survival. Due to construction of weir or barrage, this movement gets obstructed. As we all know, there are different types of fishes, but generally the fishes moves from the upstream side to downstream side in winter seasons, and from downstream side to upstream side in monsoon season. And when we construct a weir or a barrage, their movement gets obstructed. So for this reason, a fish ladder is provided so that they can easily move from upstream side to downstream side or from downstream side to upstream side. It is a structure by which the flow energy can be dissipated in such a manner as to provide a smooth flow at sufficiently low velocity, not exceeding 3 to 3.5 meters per second. In rivers, water flows with very high velocity, having very high energy. So by the construction of fish ladder, the energy of the water is broken or dissipated in such a way that the velocity is not exceed 3 to 3.5 meters per second, so that fishes can easily move from one side to another side. In the fish ladder, the fable walls are constructed in a zigzag manner so that the velocity of flow within the ladder does not exceed 3 meters per second. Here is the figure of fish ladder. The fish ladder is constructed in a zigzag manner. These are the fable walls which are constructed in a zigzag manner. They are constructed so that the velocity of the river water is broken and it should not exceed 3 to 3.5 meters per second. When the river water strikes these fable walls, the velocity breaks, and as a result the fishes easily move from one side to another side. The width, length and height of the fish ladder depends on the nature of the weir and the type of the weir or barrage. So the design of fish ladder depends on the type of fishes which will move, or the nature of the river, and also the type of weir or barrage which is constructed. So the width, length and height depends upon these conditions. This is the figure of a fish ladder. Waters come from this direction. It's this fable wall. This wall is known as fable wall. When it hits this fable wall, the velocity of water decreases and it moves in this direction. Again, when it hits this fable wall, the energy or the velocity of water is decreased, and in this manner the velocity is decreased up to 3 to 3.5 meter per second, so that fish is easily moved from one side to another side. The next component is canal head regulator. A structure which is constructed at the head of the canal to regulate flow of water is known as canal head regulator. So the structure which is constructed for regulation of water at the canal head is known as canal head regulator. It consists of a number of piers which divide the total width of the canal into a number of spans which are known as bays. The canal head regulator consists of number of piers which are provided to divide the total width into number of spans, and these spans are known as bays. The piers consist of number tiers on which the adjustable gates are placed. By the construction of piers, we attached the adjustable gates on these piers. The gates are operated from the top by suitable mechanical device. Also, a mechanical setup is provided at the top for the operation of these gates. A platform is provided on the top of the pier for the facility of operating the gates. Also, a platform is constructed for the easy operation or for the facility of operating of the gates, and this platform is provided at the top of the piers. Here are the main functions of the canal head regulator. Number 1, it regulates the supply of water entering the canal, means the amount or the quantity of water is regulated through the canal head regulator into the canal. Number 2, it controls the entry of silt in the canal, means the clear water enters the canal and the silt is removed through the canal head regulator. It prevents the river floods from entering the canal. When floods came in the river, the canal head regulator gates are closed so that the flood water does not enter the canal. Next point is the water from the under sluices pocket is made to enter the regulator bays so as to pass the full supply discharge into the canal. The maximum height of these gated openings, called head sluices, will be equal to the difference of pond level and crust level of the regulator. So the water from the under sluices is made to pass into the canal head regulator, and the maximum height is the difference of the pond level and its crust level of the regulator. And the maximum height of the gated openings is called head sluices. The entry of silt into the canal is controlled by keeping the crust of the head regulator by about 1.2 to 1.5 meters higher than the crust of the under sluices. So to remove the entry of silt into the canal head regulator crust is keep about 1.5 to 1.2 to 1.5 meters higher than the crust of the undersluices, so that the silt which is deposited at the crust, so the silt which is deposited at the undersluices crust level does not enter the canal head regulator. If a silt excluder is provided, the regulator crust is further raised by about 0.6 to 0.7 meter. Silt excluder sometimes also provided, which is used for the exclusion of silt, and in that condition the regulation crust or the regulator crust is further raised by 0.6 to 0.7 meters. Silt gets deposited in the pockets and only the clear water enters the regulator base. Silt pockets are constructed in which the silts deposited and the clear water enter the regulator base. The deposited silt can be easily scoured out periodically and removed through the undersluices openings. As we already studied that undersluices are provided in the diversion headwork, and through these undersluices the deposited silt is periodically removed. And this is the end of our lecture number 3.